Have you ever just looked at one of humanity's greatest achievements? Something so huge, so mind-bendingly complex, it almost seems like magic, and wondered, how on earth did we pull that off? Well, today we're going to look at one of those moments, and in doing so, we're going to uncover a secret about your own brain that you probably never even knew was there.
July 20th, 1969, the Apollo 11 moon landing. You know, that single sentence marks the absolute peak of a massive, incredible effort. It was a triumph of human will, for sure. But according to mathematician Keith Devlin, it was really a triumph of two very specific, very human abilities, both working in perfect sync. So on one hand, you've got language. It's like this invisible thread that connected thousands of scientists, engineers, and technicians, letting them all work together on this one crazy, audacious goal. And on the other hand, you have mathematics. Every single bit of that mission was calculated, from the flight path to that final landing where, they had just seconds of fuel left to spare. And this right here, this is the central mystery we're tackling today. We all basically master our native language by the time we're, 4 years old? And yet for so many of us, math feels like this completely alien tongue. Why is that? Well, the answer is going to surprise you, because as it turns out, these two superpowers are a lot more related than you think. Okay, so to solve this puzzle, the very first thing we have to do is bust the single biggest myth there is about what mathematics actually is. Let's start with a kind of provocative idea here. What if I told you that the thing you probably think of as math, the thing you might even fear or dislike, isn't really math at all?
See, most of us think math is just arithmetic, endless, boring calculations. But that's kind of like saying that literature is just about spelling. Real mathematics, the kind that got us to the moon, is something way, way bigger. It is the science of patterns. Mathematicians are explorers of patterns. They study the patterns of shape in geometry, patterns of motion in calculus, patterns of reasoning in logic, even the patterns of chance you see in probability. It's a grand exploration of structure itself. And numbers? Numbers are just one of the tools they happen to use to describe it all.
So, this new definition of math, this idea of it being about patterns, leads us to the absolute core argument of this explainer. And it's a claim so bold it might sound kind of impossible at first. That's right. Keith Devlin's big idea is that the so-called math gene and the language gene are one and the same thing. The very hardware in your brain that makes you a fluent speaker is all you need to be a mathematician. So, how could that possibly be true? Well, it all comes down to a single concept: abstraction. Think of our brains evolving in stages, like climbing a ladder. Lots of animals are at level 1. Some smart primates can get to level 2. Thinking about something that's not right there in front of them. But humans, we made this incredible leap to level 3, thinking about things that might not even be real. Think unicorns, or future plans, or complex stories. That ability is language. And mathematics, Devlin argues, is just taking that skill one little step further, to level 4, reasoning about purely abstract things that have no physical form at all.
So here's the crucial question. What was so important? What evolutionary pressure was so intense that it pushed our brains to develop this incredible level 3 ability? It wasn't to invent calculus, I can tell you that. No, it was for something far more common. Something we all do. You heard that right, gossip. It sounds funny, but when you look at studies of human conversation, you find that about 2/3 of the time, we're talking about social stuff. Who's doing what, with whom, their relationships, their motivations, their past actions. But just stop and think about what gossip actually requires from your brain. To keep track of all the characters in your social circle, your brain has to manage this huge, abstract web of information. People, who's friends with who, who's mad at who, what happened last year. This is exactly the kind of abstract structural thinking that you need to do higher mathematics. And that brings us right back to our paradox. If you're an expert at keeping up with social drama, why aren't you a math genius? You can follow the plot of the most complicated TV show with dozens of characters. No problem. You clearly have the mental hardware. So why does the struggle with math feel so incredibly real?
Well, there are two main reasons. First, Your brain is basically playing an away game. You're applying a skill that it perfected for the social world to the totally abstract world of math. It just takes time to get comfortable in that new territory. And second, we confuse how math is discovered with how it's presented. School teaches you the final, polished, perfectly logical proof. But that's not how mathematicians actually think.
The actual process of doing math is creative, it's intuitive, it's messy. It's a journey of exploration, full of wrong turns and sudden insights. It's not a rigid march of logic. The formal proof, that's just the cleaned-up map you draw for everyone else after you've already found your way to the destination. So if the struggle isn't about your ability, but about perspective and process, what does that really mean for you? Well, our final section here builds to a pretty empowering conclusion. So what percentage of people actually have the math gene? The huge takeaway is this: almost everyone. We're talking about 99% of the population. You were born with the mental equipment. It's the exact same ability that lets you speak, that lets you understand stories, and lets you navigate your incredibly complex social world. And this points to a really powerful shift in your mindset. What if you started to see mathematical objects not as cold, hard symbols, but as characters in a story? For these lightning calculators like Wim Klein, numbers literally are friends, with their own personalities and relationships. They see mathematics as a whole world to explore, full of familiar faces. So, the next time you think to yourself, "I'm bad at math," just remember, your brain is already an expert at decoding complex, abstract systems. You do it all day, every day. The world of mathematics isn't some locked fortress that you can't get into. It's an open landscape, and your brain already has the key. The only question is, where will you decide to explore?